This video, we're taking a look at variables and naming conventions. We're going to be writing our first program using variables. Before we do that, we'll take a look at PowerPoints that you should have already looked at and updated in your notes. Guys, you need to be looking at these PowerPoints as if they were your textbook. The state has provided. The state doesn't give us any textbooks for this course. What they do give us is PowerPoints. These PowerPoints should be treated as your textbook. So when you read these PowerPoints and you're updating your notes, you should be reading them and paraphrasing your notes. You wouldn't get a textbook from another class and then sit down and just copy word for word everything on the pages of those of that book into your notes. You shouldn't be doing that with these PowerPoints either. Read the PowerPoints, then go back and reread them and put some things in your own words. And I'm going to review this with you so that it'll give you another opportunity, another exposure of seeing the information that's in these PowerPoints before we actually create a demo program that's going to demonstrate the data types that we're looking at. All right, so let's take a look here at the slides. Let's see. Yeah, we're going to be declaring variables. And if we're looking at it from a vocabulary standpoint, the variable is just the name place in RAM. This is where in the computer hardware your data is being stored. Let's see. Here's something this is very notable. Your variable can only hold one value at any given time. We can change values throughout the course of the program, and we expect to do that with a variable. But at any one time, it can only hold one value. When I give it a different value, the previous value goes away, and then it has a new value. Here's the syntax for creating our variable. There's three parts to it. We have a keyword dim, and that's short for dimension. It's telling Visual Basic that I want to create something. I want to bring something into existence, and it's in RAM is where it's going to bring it into existence. So it's actually going to affect your computer hardware when you do this. The second part, variable name, that's whatever you decide to name your variable. This is how you as the programmer will refer to this data, and this will point to wherever in RAM that Visual Basic is putting it, and it allows you to have access to it from your program into RAM. The data type, you're telling it what type of data to expect. Now remember the analogy, the variable is the container, and the data type says what kind of container is it going to be. In the classroom discussion that we had, I gave the example of a 5-gallon bucket and a laundry basket. A 5-gallon bucket is meant to hold water or liquid, and it does that very well. But at the same time, if I had some dirty laundry and just threw it in that 5-gallon bucket, it would hold it without much of a problem. A laundry basket, on the other hand, is specifically designed to hold laundry. Works great with dirty laundry, but if I try to take the water from the 5-gallon bucket and pour it into my laundry basket, it's going to make a mess. It is not going to work. And when we start talking about the different data types, our data types will work the same way in the sense that some data types are somewhat flexible and can hold different kinds of data, whereas other data types are very, very strict and will only hold the type of data that they were intended to hold. Now, when we come in and we're choosing our variable name, there's a few things that we want to look at it from the standpoint of the rules of Visual Basic. What will it accept as a name and what will it not accept as a name? But there's also a term called Hungarian notation. I'll refer to it as Hungarian naming convention. You need to be familiar with that. And if you follow Hungarian naming convention, you will always comply with the rules of Visual Basic. Let's see, there are keywords. So when we talk about keywords, dim, as, those are keywords that we've already gone over or that we've seen in the syntax. You cannot use keywords except for their sole purpose. So you can't use dim anywhere else other than declaring a variable. Since we're going to see the as comes before your data type. So that's what we mean by what is a keyword in Visual Basic. We've already gone over the data types in the classroom discussion. We looked at 9 of them. The information that comes from the state, they have 6. I've included an additional 3. I have short, I've put in long, and I put in single. I think those are important for you to know, just so we can see how things work. You're going to be expected to know the value ranges. And like I said before, if you understand how RAM works, if you understand how the binary system works, you can, with some degree of accuracy, calculate how much information the data type can hold, and the storage amount right here, and how big of a deal that is. So with a short data type, it takes up 2 bytes of information. Well, the maximum value that 2 bytes of data can hold is somewhere around 64,025, I think it is, somewhere around that. But the highest number that a short data type can hold is 32,000 and some change there. So why is the big difference? And it's because you see here, it's the negative values. Not only does it hold positive values, but it also holds negative values. Now when we go over to real numbers, the single, double, and decimal, we're talking about the number of digits it can hold, not the highest value that it can hold. Let's see, the Boolean is going to hold true or false, but it also can accept a 0 or a 1. And the string, this is the one that's going to be the most flexible. This is kind of like the 5-gallon bucket in the sense if I have dirty laundry, I can throw it in there, but it works really great with water too. Your numerical data types are going to be your laundry basket. Numerical data types will only hold numbers. Your string is much more flexible. I can hold it as I can put numbers in there also, but it's going to work with non-numerical data. Here's a variable naming rules. You can't start with a number. You can't start with a special character unless, of course, it's an underscore. From Hungarian naming convention, camel case. Here's an example of camel case right here. You're going to hear the term camel case. Camel case is the first letter is always lowercase. The first letter of each subsequent word is uppercase, and there's your examples. And let's see. Okay, these are the rules for Hungarian naming convention. In other words, you need to have you should have a descriptive name for it. Here's examples of descriptive names. And if you notice here, you're starting off with prefixes. So when you create the variable, you should give an identifier that has a prefix, a descriptive name, and it uses camel case. And that's in line with Hungarian naming convention. Let's see if I've gone over that. All right, initializing your variables. We should be in the habit of initializing our variables in Visual Basic. There are some other programming languages that require it. Visual Basic, we can get away with not doing it, but the curriculum wants you to be in the habit of doing it. So all initializing it means is that when you create it, you're also going to give it a specific value. Lots of times we're just going to go ahead and give it the default value. And that's all there really is to initializing. But you need to be familiar with the term. You need to know what it is. So if you're ever asked, initialize a variable, then you know exactly what's going on. Okay. All right, down here they're saying nothing is a keyword. Please don't misinterpret that as there are no keywords. It means the word nothing, N-O-T-H-I-N-G, that is a keyword. And we're going to use it with strings. Just like the example here, when we're saying string is assigned the value of nothing, that's the same thing as putting your empty quotes in this way. It just means I don't want anything in there. I want it to be empty is basically what you're saying. Here's an example of a variable being declared and initialized to the value of 10. It's declared as an integer. It has a descriptive name. It's using camel case, and it has the prefix. And that is the review of the PowerPoints. Now, once again, let me put some emphasis on this. Hopefully this is maybe around the 4th time that you've seen these PowerPoints. You should have, before we even had the classroom discussion, you should have read the PowerPoints once, and then you should have gone back and reread them while you were paraphrasing and updating your notebook, and then we saw them in the classroom when we had the classroom discussion. Now you're seeing it on a demo, and that this should be your 4th your force exposure to this. If it's not, then you're really cutting yourself short. You're losing some opportunities. No one's going to get this. No one's going to understand all this just by seeing it one time, and then it all makes sense, and then you do it, and you retain it, and you remember it, and you're good with it. You need multiple exposures. So please keep that in mind. If you haven't done that this time around, please make sure as we go through the course you are doing that. Let's go ahead and get the PowerPoints out of the way. And let's create a new project. Alright, once again, we're in Visual Basic. I'll make sure it's a Forms application. I am going to give it a descriptive name. So, descriptive name for this would be data type demo. This is standard 4. And I'm going to go data. Why can't I get a capital T? Data type demo. And let's go ahead and create that. On this data type demo, we have 9 data types. I'm going to use buttons, labels, and a text box. And let's get the toolbox pinned open while we're adding the objects. And let's see. I know I'm going to want a label. No, I want a text box. Here's my text box. Okay, I'm going to want one text box, and then I'm going to want 9 buttons. I want one button for each data type that we've been going over. And let me get these out of the way here. I'm going to want all. I didn't mean to do that. Let's get these out of the way. Alright. Now, here's another opportunity. As we're going through here, one thing you can do is you can slide these around. You can use the blue lines to help you align things. But I do want to show you as we go through, I want to show you easier ways to do this. So I hope you're paying attention. I'm going to select all my buttons, and I'm going to come up to the Format menu. In Format, I have align, horizontal spacing. I have all these options in here. This alignment is going to really help me out. I'm going to align everything to the. I'm just going to pick right. Let's go to the right, and then I want to increase my spacing. Horizontal spacing, increase. I got my horizontal and my vertical mixed up, didn't I? All right, sorry about that. You can laugh at me later. Let's go with let's go to the right. Format, vertical spacing is what I wanted. Let's increase my vertical spacing. There we go. Let's come down here. Let's reselect, and I got my text box in there again. All right, let's get that vertical spacing going again. Increase. Increase. Alright, and now I'm going to make it the same. Vertical spacing, make equal. And now I'm actually going to decrease it. Tighten it up just a bit. Decrease. And I think that's good. Now give myself some room. And I'm going to create 9 labels. Okay. Let's bring those over here. All right, once again, go to Format. And let's see, go to Alignment. And let's align them at the right. And I want to go to vertical spacing, increase my vertical spacing. See, they match up here. And since I want these to match up, I'm probably not going to, let me do it just a little bit more, maybe save myself a little bit of dragging around. I wouldn't expect them to line up perfectly, but it'd be great if they did. They're close, and I'm going to later go ahead and fine tune them in just a minute here. I want to work with my buttons first. Let's bring all this up. I'm just going to fill the top with that. Okay. All right. I have all my objects on the form at this point. I'm not going to need my toolbox anymore, so let's go ahead and unpin the toolbox. What I'm going to do for each data type, I'm going to come up and I'm going to change the text I'm going to change the name. You see right here, this is the name property. You should already be familiar with it, but once again, it's another exposure. It's more practice. Change the name property to, let's go with the short. Let's do the numbers first, and then we'll do the non-numerical. And then change the text property to short. And I am going to do that with each one of these. Short integer. Did I spell integer right? Okay. Now, I'm going to go ahead and plan on speeding this up during the editing process. So I'm not going to talk much. I'm just going to go ahead and change these, change the name property and the text property for each one of these buttons. And then let's hope that my editing is good and that we can stay in sync. So I'll be back in just a second. Now, what I'm going to do with the labels. Right now, the labels are on auto size. There's no background to them. And I want to change around how the labels look right now. And I have 9 labels. I want to do the same thing to these labels. And I want to show you how to do that. Once again, this will save you a lot of time, so please pay attention to this. I'm going to select all my labels. I want to turn the auto size off. Auto size means that the label will change its size based on the text that's in there. I want it to be at a fixed size. So with all my labels selected, I'm coming over to the properties window and I'm going to look for auto size and I'm going to change it to false. And now I can size my labels. Now I'm going to position them a little bit better and I'm going to bring them out to where they match up with the text box, and you see the blue line snap. And now I have them at the same width. Makes it look a little bit nicer. And some of these I actually want to see how far out I can get them. Next thing I want to do is change the border style from none to fixed 3D. and that makes them a little bit more visible. And just for this, since we're trying to practice changing our properties, I'm going to change the background. Let's see, the back color is what I want to change. And let's go with something. Let's go with yellow. Can I get yellow? Yellow. All right. Now for text alignment, come down to text alignment. I don't want it to be top left. I have 9 choices for a text alignment. I can have it, let's see, at the top, middle, or bottom. And I could have it top left, middle left, bottom left. I'm going to go with center. Just because, except for the numbers. I'm going to select the numbers to be right aligned. And I have all my numbers down. Come on now. Down there, first 6 are numbers, so I want those to be text aligned to the right. Middle right. And let's go ahead and put the non-numerical text aligned to the left. Middle left. All right. And the text alignment for the text box, let's come up here to the text box. And let's see, text align is to the left. That works for me. And the name, txt, input. All right, so let's change the, we are not going to change the name property of a form, but I do want to change the text property of the form. Data type, demo. All right. Now we're ready to look at the code. And because of my mistake earlier, the code window is already open, but please remember there's more than one way to get there. This is one that you are going to need to know. View code. And if you ever forget what all the options are, just come to the view menu and here's code. You can view your code there. You can click on the button. You can do F7, or as you have seen, you can double click on an object and it will create it for you automatically. For example, I'm going to double click on short and it created it for me. Form 1, I didn't want in there. I'm going to get rid of that. Now, the other way that we're going to be creating them is coming up to the class drop-down list. And I want to create these in some sort of sequence that makes sense, and it's going to be the same sequence that the buttons were listed down there. So btn integer and a click procedure. So those are 2 ways that you can create it very quickly. So let's go ahead and let's declare a variable and let's assign it the value, and then we can test that. So to declare a variable, keyword is dim, and then I want to have a descriptive name using Hungarian naming convention. My prefix for short data type is going to be SHT. And I'm just going to give it a descriptive name. It's going to be input as, and then the data type. Well, this is going to be the short data type. We know that. Short data type. Now, we're going to initialize it to 0. And there we have just created a variable. We use the keyword dim. Here's our identifier right there. This is Hungarian naming convention with a prefix. Camel case is descriptive. Here is the data type, and we have initialized it with an assignment operator to a value of 0. Now what we're going to do is we're going to take and we're going to make a specific assignment. We're going to input is assigned the value of whatever happens to be in the text box. The text box is txt input, and I misspelled it. Input, And then we need to access the text property of the text box, because that's how we access whatever the user typed in. And to get that, we use dot notation. There's our dot, and then we type the word text and hit enter. Now we have that value in our variable, and we can display it in the label. So let's see. Did I change the name properties of my label? Let's go back and check. Look at that. I never changed the name properties of my label. I need to go back and change the name properties of my labels. So we've got to stop here. Let me just do it on one. Actually, if things work well, I'll be able to edit this out, but if not, you're going to have to bear with me as far as me going in and changing these. LBL short. It looks like I got ahead of myself, didn't change out the text property either. And let's go ahead and change the text property. You know what? I'm actually going to leave it. No, I'm not. I'm going to take that out. I don't want that in there when we start the program. So let's go to text. There we go. And all I did, I just put a space in there, and then I hit enter to get rid of the property that was already there. Now, sorry about that, guys. So let's pick up where we were. Now I want to access the text property. I'm going to make an assignment to the text property of that label. Remember, I reference the label object, and then I use a period, a dot, to access the text property. And now I'm going to make an assignment to that. I'm going to assign whatever happens to be inside of short input. And let's go ahead and test that. So I put a value inside of here. Let's go with, let's do what was in the PowerPoints. I think they had 10 in the PowerPoints. And I click on the button that's labeled short. It's going to trigger this code. And the first thing that's going to happen is going to create the variable. It's going to assign whatever's in the text property, the text box, to the variable. And then it's going to take whatever's in the variable and assign to the text property of the label. And that's when we should see it. And there it works. Okay, so let's change this around. Let's change that to 20, and that's working just fine. Let's change it to 32,000, and that works just fine. Let's change it to 33,000, and our program crashes. There it is. We have an overflow exception, an unhandled overflow exception. This is a crash. This is because we put a value inside the variable, or we attempted to put a value inside the variable that was too large. There was not enough RAM to handle that particular number. So what is that number? This is where we're going to get in and actually take a look. What's that number? Let's see if I can remember what the number is. 32,767. Yes, but if it's 32,768, it's going to crash. because the maximum value that a short data type can hold is 32,767. And the reason for that is if you take ones and put them in all the bits, because there's 16 bits in 2 bytes of data, and you put a 1 in each one of those, it gives a maximum value. Now, once again, we've already identified that that's a lot more than 32,000, but when you use it for both negative and positive values, 32,767 is the highest value that's possible for the short data type to hold, because it's only taking up 2 bytes of RAM. All right. Now, I'm going to do the same thing with all the rest of them. Let's go with... actually, at this point, you have enough to go on and build the rest of this program. I'm going to go ahead and write the code for all this, and if the editing works out well, then you won't have to sit and watch that. But if the editing doesn't work out well, then I'm going to apologize up front as you watch me code a lot of this information. Okay, that should be 9 event procedures. Made a couple mistakes, get a little slow. I hope you were watching the good parts at any rate. This is reinforcement on how to access the class dropdown and the methods list. It's good practice for you. Later on we'll get into how we can make things a little bit more efficient. This is not an exercise in efficiency at all. This is just an exercise in practice doing some of the very basic information. So let's take a look. Let's run it. Let's see what happens when we put in a number 57 for short, integer, long, single, double, decimal, boolean, character, and string. And you see how that one value works with all of them. Let's change this over to a 0. That works. Everything's working here. You're going to see Boolean's going to react a little differently. False. Alright. What about 12.81? Short gives me a 13. Integer gives me a 13. Long, so the whole numbers are rounding up. Single accepts the value. The real numbers are accepting it. Boolean, give it as a true. Character truncates anything after the first value, and the string accepted it. This is where I was talking about the string is more like your 5-gallon bucket. Our numerical variables are more like our laundry basket. Because let's take and put a letter of the alphabet in. Apple. I want to start at the bottom. String takes apple. Character just takes the A, truncates everything else. A Boolean. Boolean is going to crash. Boolean would not accept that. The numbers would not accept it either. The Boolean and the numbers react to it the same way. Will the Boolean data type accept any letters at all? And the answer is yes. Boolean data type will accept the letter T, or it will not. Will it accept the word true? It will accept the word true. Will it accept the word false? It will not accept the word false. Will it accept an F? It will not accept the letter F. So what input will Boolean accept? A Boolean will accept a 0 or 1 or true or false. Well, let's crash a single. Well, can we crash a single data type? No. What happens? The maximum number of digits for a single is 7. 1, 2, 3, 4, 5, 6, 7. That should work well on a single. But if I put an 8, you get the E. Double, that works all the way up to 15 digits. 9, 10, 11, 12, 13, 14, 15. This should work fine in a double. But if I add a 16, okay, we get the E. Your job at this point is to go through, test your demo, and find out what will make these crash. The decimal, 29 characters. Character, you're not really going to make it crash. It's going to truncate everything after the first letter. String, you're not going to make it crash. It'll accept. It's a variant as far as the amount of RAM it takes up. So it's going to be very flexible for you. But at this point, go ahead and complete your program. Test it out. Watch it crash. Your maximum value for your integer is 2.2 billion. You can go and play with long and find out what's the maximum value a long can hold. But remember, it takes 8 bytes of RAM, so that's a pretty large number. But you can figure it out. Do the math and figure it out.